What is up, Twitch? So, if you're subscribed, you might have seen that in the last few days, I've been trying to set up some stream stuff again. This is something I haven't done before, so I haven't ever done any live code, anything, ever. It always kind of spooked me. So I figured the best way to get over being spooked by it is just to do it. So what I'm going to try and do, hopefully, is in December, I'm going to try and do the Advent of Code challenges. This is this website, adventofcode.com, and that's got basically 25 challenges that release one a day over the Christmas period. And yeah, my idea for this is that basically I've been doing a lot of tuition over sort of the COVID period, and I found that a lot of the people I tutor, they don't sort of have many prompts to learn to code from, and sort of the hardest thing seems to be finding these prompts to get people to start coding. And I know for me, when I first started coding, the stuff that made a lot of sense to me was things like Project Euler or Code Wars, where they sort of give you a little task and it'll just be, you know, write a function that sorts a list or finds the biggest number in a list. And I also think that there's a sort of transitionary period for a lot of people where they learn how to program, so they might know how to they might know how to do Scratch, or they might know how to do some Python up to a point where it's fun. And then it kind of becomes this like big sort of monolithic thing where it's like, okay, now you know how to code, learn GitHub, do this, learn this tool, download Anaconda, and then come back at the end of it. And then after all of that, then you can like officially be a programmer. So I feel like Advent of Code does quite a good job of like pushing out what you're capable of doing. It makes you think a lot, and it's also quite fun and quite sort of seasonal and quite silly as well. So I thought I'd give it a bit more of a go. And yeah, like I say, my plan here is that I'm going to write them all in Python as best as I can, but I'm going to try not to each day assume any knowledge about Python or programming. So I think that's going to be pretty problematic, and I'm sure I'm going to sell that short. But yeah, the idea is, you know, even things like if statements and for loops, I'm going to go back and try and define as I use them. So yeah, it might be a bit weird. I'm not sure that anyone will enjoy it, but I also enjoy doing the Advent of Code stuff, so at the very least it'll sort of maybe make me do a couple of days of Advent of Code stuff. So yeah, obviously it's not 2020 yet, so what I've done is gone to last year's, so you can go back to any of the old years by going on 2007, adventofcode.com/2007, so there's loads of stuff, but yeah, I'm going to try and do the 2020 ones as they come out, and hopefully it'll get some other people coding, and I'm definitely going to send it to some of my students. So anyway, this is just a test stream to see if the recording quality is good, if the stream quality is good, and hopefully it is. And I'm going to try capturing that all on Twitch, but I'll put it on YouTube as well. So yeah, just as a test, I'm going to go through the Advent of Code 2019 Day 1. Day 1, the tyranny of the rocket equation. Santa has become stranded at the edge of the solar system while delivering presents to other planets. To accurately calculate his position in space, safely align his warp drive, and return to Earth in time to save Christmas, he needs you to bring him measurements from 50 stars. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first, and each puzzle grants 1 star. Good luck. So that's basically describing how Advent of Code works. So each day you get a challenge, and if you complete that challenge with the inputs they give you, then you'll get 1 star. And then usually the challenge has like a twist that makes you go back and not refactor, but sort of change some of your code to deal with like this new requirement. So the actual challenge, the elves quickly load you into a spacecraft and prepare to launch. At the first go, no-go poll, every elf is go until the fuel counter upper. They haven't determined the amount of fuel required yet. Fuel required to launch a given module is based on its mass. Specifically, to find the fuel required for a module, take its mass, divide by 3, round down, and subtract 2. So for example, for a mass of 12, divide by 3 and round down to get 4, then subtract 2 to get 2, and then there's a few more examples here, but I'm not going to go through them just yet. And then the other part, the fuel counter needs to know the total fuel requirement to find it. Individually calculate the fuel needed for the mass of each module, which is your puzzle inputs. Each puzzle you normally get an input that looks something like this. It'll just be a big list of numbers. And yeah, add them together. So what is the sum of the fuel requirements for all of the modules on my spacecraft? So I'll have to run that algorithm on all of these numbers. Now, that's jumping way ahead, so let's not worry about that yet. So first thing with this program is let's look at which parts of this prompt are actually relevant to coding. So obviously this first bit here is just talking about the advent of code stuff. This is kind of some fluff that we don't need to know about. This describes sort of the core algorithm, the sort of mathematical process we need to put each of our numbers through. And then we've got these test cases here. And then we also need to sum them, which it doesn't give us, but we can figure that out anyway. So what I normally like to do is just grab this first bit of text. And this is a website called repl.it. So I'm going to send this link in the Twitch chat. REPL.it basically lets you write code in your browser for loads of different programming languages. So you don't have to do Python. You can also fork my work, so you can see this work if you go on the link. And they do all sorts of other stuff. So you can write JavaScript, you can write R, you can write most sort of common languages. But it's very useful because I think in a lot of early programming, you can go do these courses online, but many of them don't tell you how to set up Python or how to set up a particular language where you can go to run that code or how you run that code. And some of that can be reliant on, you know, typing stuff in the command line. And I think all of that is just, it's too scary to get started with. So skipping that altogether, we've got this, we've got REPL. You write your Python code here, you press play here, and it'll run over here. This is also a Python REPL here, so you could write individual lines of code. So we could write something like 2 + 2, and it'll calculate that for us. Or on the other side, we can write 2 + 2 here, and we can run it, and it'll print. Oh no, it won't. We have to run print there. But again, that gets us past loads of this entry stuff where it's like, how do I install Python? How do I run Python? Do I already have Python installed? We don't need to worry about that. We can just sort of get coding straight away. So again, looking at our prompt there, I'm going to highlight all of this, and if I press Control and /, whatever language you're coding in, it'll comment out. Now hopefully that's readable. I'm not sure if there's... That might be a bit easier to see. Yeah, that'll do. Okay, so now we've got our comments. I'm going to just turn these lower comments into some easier inputs. So we should get that the input of 12 should return 2, 14 should return 2, 1969 should return 654, and I'm just pressing Control / and that will turn them into comments so they don't run. And 100756 should return 33583. So now I can get rid of all this. So those are our these are what we would call our tests. So if we were using a testing library, we could implement that, but for now I'm just going to write a function that deals with just this logic. And then can we simplify this? So it says we need to take our mass, so return mass divided by 3, rounded down, and subtract 2. Okay. So first of all, we can look at maths in Python. So same as in, I guess, in normal maths. You can type 2 + 2, you can type 4 - 2, and those will give you the sort of correct answers there. Now it gets slightly more complicated after that, because if we want to do 4 × 4, it's not 4x4. So instead, in a lot of programming languages, we use the asterisk key, so that should be Shift-8. So that's how we do multiplication, and then we have division, which uses our /, and that shows a decimal type. So I'm not going to go into that just yet, but we can start having a look at this first case. So if we do 12 divided by 3, we get 4. Then it wants us to round down, which in this case is still 4, so we don't need to do anything else. And then we're going to subtract 2. So obviously 12 divided by 3 minus 2. And that gives us our correct answer. We can try it again with our second case, 14. So we do 14 divided by 3. Now this is one where we need to round down, and obviously we can round down right now in our heads, but that's not going to help. So we need to come up with a way of rounding down this number before we continue. So unlike most other things you probably learnt, or if you're in school, unlike most things you learn at school, you're allowed to Google this. So don't be afraid to just Google how to round down Python. So with coding, a lot of the skill is just about how well you can Google stuff. So we've got a round function, we've got a math.floor function that will round down. So we can try that. So what will that do? Math.floor 5.5. So we don't have math, so that's a separate package that we would need to import. So let's see if we can do something else before we look at importing things. How about round? So round 5.5, so that will round up. So my thinking there is there something we can do to force it to round down? So I would search Python round function. So functions are called, you say the name of the function, and then you put these round brackets after it, and then anything you put inside is the parameters. So I'm sort of hoping that there's a parameter that I can put in that will force it to round down, but that might not be the case. Yeah, so it only takes a number and the number of digits to round to, so this isn't going to help us either. Round down Python. That's what I was looking for. So we can use something called, I think it's called casting, where you convert a type to another type. So I'll do some more details on that in a second. Okay, so we've already hit our first next thing to talk about. So there are different types in a lot of programming languages. So what this means is that, what does this mean? There's a lot of different, I guess if you, in English we have like different ways of storing information, right? So you might have something like your name. Now your name, you wouldn't describe your name as a number, you'd describe it as a word or text or something like that. So in Python, for things like that, we have something called a string, and that's denoted by surrounding something in quotes. So that would be a string. Now I think they have a type function as well, but let's just check what type things are. Yeah. So if I pass our string in there, in quotes, it'll say this is a class string. Another one we just got there is what's called an int, or an integer. So this refers to whole numbers, so 1, 2, 3, 4, but it doesn't refer to things like 0.5, 11.5, or even 1.0. So those are normally referred to as floats or decimals. And so what we can do is we can also convert between these different types. So if we use this function, str for string, it'll return the integer 2 converted into a string. In this case, all it's done is put quotes around that string, which isn't too bad. Yeah, I think that's more than enough for now. So what I'm getting at here is we can convert our float 5.0 into just 5 using this int function, and the way it does that is it just chops off the decimal part. So if we do 5.9, whereas our rounding function would round to the nearest integer, which in this case would be 6, the int function would just chop that 0.9 off and give us our 5. So that's the next bit we need for this. So we've got 14 divided by 3, which will give us our 4.66. We can use brackets to force an order of precedence around that as well if we need to, but I don't think we do for this case. So that gives us 4, and then we take away 2 from that, so we get our answer. Now obviously each time I do this I don't want to write all this out. If I do that here I'm going to be doing something like this: int 12 divided by 3 minus 2, and that's fine, that's easy for me to just type them in because there's only 4, but remember we've got this prompt here with what looks like about 100 different numbers. And I guess one of the tenets of programming is that you don't really repeat yourself, you don't really want to do stuff like this, so all we're doing is writing the same bit of code but changing this number. So this is a good place for what we call a variable. So a variable is basically a named storage for a value. So I like to imagine it as like if you had a box, like you were moving houses, you would write on the front of the box kitchen or bedroom, and then all of the stuff inside it is related to that kitchen or bedroom. And we kind of do this a lot in English as well. So if I say, for example, what is your name? You might say to me, I might say, my name is Joe. And the way you can visualize that is there's a box. On the front of it, it says something like name, or my name, or Joe's name. And inside it is the value, a string, Joe. So that kind of looks like this. So we might do something like my age. We can call it whatever we like. And you say equals, which is used as an assignment. So we're assigning the value 25 to the variable my age. And now we can access this whenever we want. We can do maths with it. We can add my age to another number. We can just print my age. We can do all sorts of stuff with that. We can increment it, so we can say my age equals my age plus 1. So maybe it's my birthday in a couple of weeks, which it is. So I might say my age, which is 25, but I want to reassign it to 25 plus 1. So now if I print it, my age is 26. So again, I know I'm whizzing through a lot of stuff there, but there's a lot of things to cover here. So now, instead of using this, this could be our sort of input instead. So I could say like input number is equal to 12, and then here I can just be saying input number. But I'm still sort of repeating myself, right? Because now I'm saying, here I'm saying input number equals 14, input number equals 12, and then using input number, I'm repeating myself even more basically. So what I'm going to do next, if we're typing over here as well, we need to print out our answers. So we need to wrap these things in a print function. So you write print, and then you put brackets around them. So this becomes the parameter to our print function. So now that'll print our answers for those. So what we actually want to do next is write a function that does this. So I'm going to do def calculate fuel, and that's going to take a parameter, input number, and it's going to return int input number divided by 3 minus 2. That should be fine. So again, another thing I've skipped over, this is much more difficult than I had hoped it was going to be. So we have the ability to define functions in Python. So you do this with this keyword, def, short for define, and you write a function name, and you open the brackets, and in here you would write the names of any parameters you want to pass in. So if, for example, you wanted to increment your age, you would need to pass in your current age, and you would be returning your age next year. So I'm just going to call it param1 and param2. These can be like comma separated values, and you can have as many as you like in here. And then you use the keyword return to return a value, so I'm just going to add them together for now. And now we can call that function if we use function name and give it 2 parameters. So if I press run here, I didn't print that, but I can run it here, so you can see it. So I can run function name, and I can give it 10 and 10, run it, and what that's doing is it's saying param1 is equal to 10, param2 is equal to 10, return 10 plus 10, which is why we get 20. So we'll cover that more as we go over this over and over again anyway, so don't worry. So now I've got this calculate fuel function, and I can actually just run, well, I need to wrap it in a print, but I can run calculate fuel 12 for this first input, then calculate fuel 14 for this one. And again, they all need to be wrapped in a print. But we won't be using this for a while anyway. Print calculate fuel. Oops. Okay, so now we should see 654,333,583, which is cool. So we've got that part of our maths correct. So what do we need to do next? So let's look back at the prompt. We've got this fuel counter upper. We need to know the total fuel requirement, which means we need to sum up all of those things before. So we've got calculate fuel. We need to sum fuel totals. I'm just going to paste in the comment for the fuel counter upper as well. Okay. So what we need to do next is we need some way of storing these values after we run them. So what I'm going to do next is I'm going to introduce something called lists. So a list is denoted with these square brackets. So that's an empty list with nothing in it. And what we can do is we can put comma-separated values in there, and we can access those values. So now if I print my list, it's got the values 1, 2, 3, 4. I can add new values to it with an append function. So I can add 5, and now if I call my list again, we get 1, 2, 3, 4, 5. I can pop off recent values, so that'll get the most recently added value and remove it from the list. If I print my list, that 5 is now gone. And what else can I do? I can iterate over the list using a for loop. So I can say for a variable name in a list name, I can print whatever's in that list. So that won't work because we don't have that list name. I've just realized as well, I've not explained that Python is indentation is important. So this function, for example, won't run if we don't indent there. It'll complain about it. And the for loops work the same way. So what I need to do is instead of printing these each time, I need to be adding them to a list. So to do that, I'm going to create a list of fuel, fuel list, maybe fuel list, fuels, fuel amounts. Fuel amounts is an empty list, and I'm going to append to the fuel amounts each time with our new value. So if I run this and I then print fuel amounts, it's just got that value 2 from that first one. So I need to do this to everything. Every time we're running, it needs to be running fuel amounts append instead. So now I've got fuel amounts, and those are our calculated fuels for our masses. Next I need to sum these, so I think there might just be a sum function built into Python. Doesn't work like that though. So maybe it takes a list. Yeah. So what we can do is at the end of this we can just print out, and we can call the sum function on the fuel amounts. And that will add up all of those numbers, hopefully, to that looks about right to me. Okay, cool. So now at this point, let's do that. Move this comment down. So I would tidy up. Is there anything else we need to do? I'm just going to change this to calculate fuel because we don't really need to know about how it works anymore. We've got calculate fuel, test amounts, summing the fuel totals, and that's our answer. So what else do I need to do? Right, so the next step looking back at it is obviously we've not dealt with the fact that we've actually got this text file we need to read in. So what I'm going to do is modify this stuff so that instead of using my inputs, it's going to read those inputs from a text file. Now again, this is somewhere that REPL.it will help us out anyway, so I can call this something like inputs.txt. And in here, I'm just going to write those inputs. So let me copy this. And I'm going to put them as new lines on the file, just like in the input. So 12, 14, 1969, 100756. Okay, so there's an example input. Now we need to figure out how do we read that example input into Python. So let's say read line by line into Python list, maybe. There we go. How do I read a file line by line into a list? And somebody's already got. Gosh. Don't actually know if it'll let me do this kind of stuff, but let's give it a go. So line in file, but I'm not in file with open file name. And what's this complaining about? Undefined name, file name, that's fine. So this needs a string, inputs.txt for line in file. So let's call that file. And that might do it. So now we should have a lines variable. That's not going to work like that if I print it. Okay, cool. So that's got all of our numbers. They are all strings, if you notice the quotes. So I'm just going to try see if I can do anything to get rid of those, or I could just ignore it. It might work anyway. Let's see if it works anyway. So now I'm going to iterate over that list. So I'm going to say for mass in, let's call this masses instead, masses. So for mass in masses, and then a colon, so we put a colon at the end of anything like a definition, for loop, if statements we'll get into later. For mass in masses, then I'm going to call my calculate fuel on the mass. So this mass it'll iterate over these. So the first time this loop runs, mass will be 12 as a string, then 14 as a string, then 1969 as a string. And we're going to do this appending as well there. So now we should be able to get rid of, oh no. Fuel amounts doesn't exist yet. That's fine. So now we can get rid of all of this. And that should, why did I write this? Is there? That looks fine. Okay, so now we're reading in our text file, line by line. So this will read it into a list masses. Then we have our function which calculates fuel from an individual mass. So I'm going to rename that to mass as well, actually. Then we have our fuel amounts empty list, and it's going to get populated as we iterate over our masses in our mass list. So we could be using like a map function there. Maybe I will. Let's give that a go as well, Python map function. No, let's not do that because it is a different thing. I guess we could, no, we can map it. We can do it. So I can do for mass in masses. Instead I can do fuel amounts equals map lambda x calculates fuel x, and that's going to run on the masses list. So this line here, line 13, is an equivalent way of doing basically what we did here. So it's going to map over the items in that list. It's going to apply our calculate fuel function, and it's going to create a new list, fuel amounts, I think. Ooh, no. Yes, because they're strings. So we need to make sure they're strings before they go in here. Sorry, make sure they're integers before they go in there. Oh no. String. Should be a mass there. Why is it not a mass? Oh, I'm running it twice. Okay, so it's here, they should be an int as well, and I need to get rid of that map. Over masses calculating fuel. Yes, okay, cool. So now that's all looking like it's working to me. So all we need to do next is change this to be our input. So I'm pressing Control A to select everything, and I'm just going to paste it in here. Oh, it is 100. And I'm going to run it, and we get an answer. Oh, that scared me. And then I'm going to put it, so here you put your answer and it'll tell you if it's correct. That's the right answer. Boom. Welcome to Advent of Code Day 1, everybody. So now it'll give you a part 2, and it'll normally make you change everything in your code, depending on how you... Oh gosh, look at this. I'm not sure I'll do this, but let's see what it says. So during the second go no-go poll, the elf in charge of the rocket equation double checker stops the launch sequence. Apparently you forgot to include additional fuel for the fuel you just added. The fuel itself requires fuel, just like a module. Take its mass, divide by 3, round down, subtract 2, so that's the same calculate function we had before. That fuel also requires fuel, and that fuel requires fuel, and so on. Any mass that would require negative fuel should be treated as 0 fuel. The remaining mass, if any, is instead handled by wishing really hard, which has no mesh. Okay, that's fine. So for each module's mass, calculate its fuel and add it to the total, then treat that fuel you just added as the input mass and repeat until we get 0 or a negative fuel. Okay. Oh, okay. So I guess my first thought is that do I need to calculate each module's fuel over and over again, or can I just calculate like it from the total? But I think because of the fact that we're rounding down and chopping off that integer part means we can't. So what we need to do is modify this function so that instead of calculating the mass once, it's going to calculate it over and over again for each input. So I'm going to simplify this again. So we've got an example. Our example 14 should still say 2. That's not really useful. Let's do... Okay, let's do this one. So 1969 should be giving us the answer 966. Answer should be 966. Oops. Okay, there's a start. So we've got our answer 654, and the answer should be 966, and we're going to get that by calling this function on the answer over and over again until it's negative or 0. So, okay. So I wasn't expecting the first one to go into like recursion. So normally when we do recursion, we need a base case, which is our first case, and we need nth case or iterative case, which will be each of those ones as it gets lower down, and then we need to return them up and add them up each time. So that means that we're going to try and call the calculate fuel function in here if our calculated fuel is positive. Fuel equals, so I'm going to say calculated fuel equals what we were originally returning. Then if calculated fuel is greater than 0, so this means that it's not 0 and it's not negative, And for if statements, we use a colon, and we're going to have to indent again. So if it is a positive number, we're going to call calculate fuel again. If it's not, so if we reach this point, then we should have our calculated fuel. So I think there's a little bit more I'm going to have to do here to sort of like bubble up the values again. But let's see. So if we try it with 966, we're going to get one number here. That number is going to be this one, and oh, sorry, we need to calculate fuel, not calculated fuel. Calculate fuel, calculated fuel. And we're gonna, otherwise, we're gonna return calculated fuel. So I know I'm pretty confident I'm missing something here because I need to be like returning a value up here. So I need something like, I need this recursive step basically where I say like calculated fuel equals calculated fuel plus calculate fuel calculated fuel. So that's what we'd call our recursive step. Just gonna run it. It's pretty good, pretty close. That's kind of upsetting because it looks like we're one number off from what we should be. So what I'm going to do instead is print out calculated fuel each time in here and just see where it's going. Because we have our example here that says it should be 654 plus 216 plus 70 plus 21 plus 5, and it's saying that should be 966. So for some reason we've lost one, but those numbers look good. Does that add up correctly? That should be 6. So what's going on there? So I'm a little concerned. I'm a little concerned. Hello, someone's said something in the chat which is really nice. So just as an intro, I'm probably in Christmas, I'm going to be streaming the Advent of Code stuff. So doing like daily code challenges, but I'm just doing a test one. If you can help me at the moment, that would be cool. So I'm adding up all these numbers, and it should be 966, but for some reason it's 965. I feel like I'm going a bit crazy. I'm going to add those just to double check myself. 216 plus 70 plus 21 plus 5. Oops. And 654 plus 216 plus 70 plus 21 plus 5. Oh! Yeah, okay. But why would I be adding up the numbers wrong? Perhaps my calculated fuel is wrong? No. I am talking to myself. I'm trying to make it educational. So those numbers to me add up correctly. So something is going missing. But let's see if we can figure it out. Yeah, it could be that it's very suspicious to me that I'm missing just one. So the number should be 966, but I'm getting 965. But if I sum these numbers myself, I get 966. So the numbers are correct, but the sum is incorrect, which like makes me think there's a rounding error, which there could be because I'm dividing by 3 and taking the integer part of that. But why would these not add up correctly is very strange to me. I guess when it finally returns calculated fuel, no. No, that should be fine. Yeah, so the mass for this one, it should be 966. So if I print mass at the start, oh sorry, yeah, 1966. And it's printing the mass each time as it gets cooled down. It does make me think, like, could I just add 1 and would the answer be correct? Which I'm going to try now, though I don't know why. Okay, yeah, that doesn't work because it's recursion. I could do it on the final case, so I could do it here, but it's not good. It's not good reason to do it. Anyway, that gives me the correct answer for that one. Let's see if they have another example and see if we're also off by 1, and that might at least give us a clue. So I'm going to try this, and the answer should be 50,346, but it's off by 1, and I'm adding 1 to the answer. Okay. Okay, so when it's that, we're off by 2. By 2, and when it's the one before, 1969, we're off by 1. So I'm thinking that maybe it's to do with the number of steps, the number of times we go into these recursive cases. Maybe we're missing. Maybe we're missing something. I guess it could be because we're dropping off this decimal part. But it does say it's still rounding down. Can't just add 1. And then let's try this other case. So 14. No. Well, let's try this 14 as well. So I think it could also be that there's they're repeating. So if it's negative, it would be adding a negative. So we could be doing like a number divided by 3, which could be 0, then taking away 2. And then we could be adding that take away 2 or adding that take away 1. But it shouldn't be happening because of the if statement. I don't know. Let's see what 14 does. That's not 14. 14 gives us 0, so it's correct. So my next question would be, how many times are we going into this loop? Print mass. So for 14, 1, 2, 3, 3 times. If I try 1969, oh, I included that 2 times. 1, 2, 3, 4, 5, 6. 6 times. And 50,364, 46 even. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So Advent of Code is like a Christmas coding challenge. So if you go on the Advent of Code website, they give you a new challenge for each day. And they tend to be like, the first part will be really easy, and then the second part will require you to modify what you've done for that code, and you like collect stars. So I've got 1 star for last year. I normally use it like when I'm learning a new language, but I thought this time I'd try and use it and just share it with some of my students and stuff so that they can try and code along. But yeah, the first question here is literally like jump straight into recursion, so I don't know how accessible it's going to be. Gosh, I'm so close though. off by such a small amount. It's really, really jarring. It's got to be this, I think. But are those numbers correct? Does it tell me the numbers? I guess I can check all of these are correct, but none of those are correct. Yeah, because it's not a number. Oh, I'm putting the answer in. That should be that. And then those should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That doesn't really make anything easier. And let's see what we got here. Correct, 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 correct. Okay, so something about this adding is just incorrect for some reason. I guess. So what will it be on the first one? So it'll be this. And then on the next run, it'll still be returning something. And here's my code if you want it. I might have to organize these a bit better actually. Oh, I guess I could make like individual files in here. I probably should have saved my answers for each one as well. Can that be a Python file? Can be. Okay. I wonder if it's just because I'm doing this out here instead of in here. Oh no. No file or directory inputs text. It definitely is. Maybe it needs to be at root. Okay. In --1/inputs text. Nope. Okay, I'm going to put that back up there. It's still wrong. Undefined name. Maybe I need like a global calculated fuel outside to be 0. And then that can be incremented instead. No, that's not right either. I guess it could be. This feels worse, this feels backwards now. No, 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 this is wrong. Oops. Okay. Okay, well I'm going to leave it there because that's an hour, and I'm going to try and keep to just be an hour. Not quite figured that one out, but feel free to tweet me at JosephAllen1234 if you do figure it out. If you can point out where I did wrong and I'll tweet it out. But yeah, thanks for watching everybody. Thanks for joining. Cool. Bye bye everybody. And transition to cool techie jazz music.